Now we have this example previously discussed, and now just imagine you have got a code not just with the two functions but 25 functions, and there is a lot of processing that's being done with the quantities calculated by this function. It will be a real mess. This is a short program, therefore it is not that clumsy. But if there are very many functions to be defined, which would often be the case when you take involved problems, it's going to be an issue to figure out what the code really does. So in such cases, we have another nice feature in Python which can be employed to simplify the code structure. So what is the modus operandi? Divide and conquer. So let us look at the previous program itself. So I had all the definitions in the code. The processing of these outputs are also done within the code. Now what I do, I split this code into two parts. So I actually make two Python codes, one which has only the definitions of functions, and another code which does only the processing of output generated by these functions. So I have split this into two parts. So the first one I call as GUOM underscore figures. It's a Python code, and it has all the definitions of various functions that are invoked by the code GUOM underscore module. Now when I try to formulate this code module, what I do, I import GUOM underscore figures because that has all definitions of all the functions required by this code module. And when I want to invoke a particular function, let us say draw circle, I invoke it by the following syntax. So I have the name of the file which contains the definition of draw circle. So I write that name without, of course, that extension .py. So after the name of the file, I put a dot and give the name of the function that is defined within that code. In this case, draw circle, and it depends on one parameter. So I call that as RAD. So whatever value of RAD you pass on from the main code, it will invoke this draw circle from figures Python code and then draw this circle. So it is very similar to what you do with the turtle. So you say turtle.turtle. So it is exactly like that. So you import turtle, then you define, let us say, turtle by name A, which is turtle.turtle within parentheses, exactly the same structure here. So GOM underscore figures dot draw circle. And similarly, if you want to invoke polygon, of course, you will have exactly the same syntax. And instead of draw circle, you will have draw polygon with the relevant number of parameters put in there. So what is the general structure of modular code? So you define various modules, not necessarily one module. You can have more than one module. And you need to import all the modules into the main code that you want to write. So you can have all the modules stacked in the beginning and then have the Python statements which will use these modules. Or you can locate the module anywhere in the code, but keep in mind that before you invoke the module, you should have defined it already in the code. So that is spatially, if the invocation of the module occurs in statement number 10, the import of that module should have happened before statement number 10. That's what it is.